Okay, so today students will be able to identify features and predict results of exponential functions. An exponential function is a times b to the power of x. Is when you have to the power of x. The exponential parent function is y equals e to the x power. It goes straight up like that. Exponential growth is when you read like a book, it's going up. Exponential decay, when you read like a book, it's going down. Okay, compound interest, and this is super awesome. It's my favorite thing. We're going to start getting into it. A is the amount after t years, so after the t years. P is the amount you start with. R is the interest rate, and T is the number of years. Okay, so you get to predict how much money or how much something is worth after a certain amount of years. Okay, so that's more fun. All right, here we go. So getting started. First says 3 years ago, Andy invested $5,000 in an account that earns 5% interest compoundly annually. So the equation is f of x equals a times b to the x power. Okay? A is the initial amount. And b is the common ratio. Oh, by the way, put your name on your paper. Okay. Okay, so what that's saying is the 5% interest rate, since it's growing, okay, because they're earning, so it's going up, okay? So it's going to be 1 plus the interest rate. We don't put 5%. Instead, we put 0.05, okay, because that's the decimal. 1 plus 0.05 is 1.05. Okay, if it were going down, we would do 1 minus the interest rate, okay? That gives you the common ratio. So that's why it's 1.05, okay? Because it's 1 plus 5%. Remember, just a refresher, if we have 5%, what you do is you move the point here over twice, the decimal point over twice, 0.05. That's how you change it to a decimal. All right, so then we're going to fill in the chart, okay? We're going to fill it in with 0, 1, 2, and 3. So take out your calculator, and we're going to type in the equation into y equals. So it's y equals 5,000 times 1.05 to the power of x. Okay, then go to your table, second graph. All right, so for 0, it's 5,000. For 1, 5250. 2, that number. 3, that number. Okay, so we're going to write that down. So 5,000, 5250, 5512.5, and 5788.1. Is this growth or decay? So as this increases, this one is also increasing. So is it growing or is it decaying? It's growing. Okay. How much money does Andy have now? Well, this happened 3 years ago. So after 3 years, how much will he have? 1, 2, 3, 5, 7, 8, 8, and 10 cents. Okay. How much money will Andy have in 10 years? So we found 3. So let's go back to our table on our calculator. Find 10 years. There it is. 8144.5. 50 cents. All right? Not too hard, right? Let's do number 2. Number 2. Mr. Dudley purchased a car for $15,000. The car depreciates. If you ever see like D, that usually means going down. Okay? At a rate of, this should say 15%. So change it to 15%. Depreciates at the rate of 15% each year. Okay? So let's write our equation for this. Remember, it's y equals what you start with, which is 15,000, Now, in here needs to be either 1 plus or 1 minus 0.15. Okay, because 15%. Is it plus or is it minus? Well, if it's going down, it's minus. So 1 minus 0.15 is 0.85. Okay, to the power of x. So that's the equation we're working with here. Okay, if you were to type this in your calculator, which we're going to, you'll see that the graph matches. So y equals 15000 times 0.85 to the power of x. If you graph it, it's going to use this box only. Oh, it's 15,000. It's going by the thousands. It's way up there. All right, let's go to our table. Okay, so again, I want our table to start with 0, 1, 2, and 3. And we're going to write down the numbers. So for 0, you write this. 1 year, it becomes this. 2 years, this. It's going down. That's what happens to cars throughout the years. Okay, so when you first bought it, it was $15,000. Well, according to our table in our calculator, after 1 $12,750. And then after 2 years, it's $10,838. And after 3 years, it's only $9,211.90. Okay. So, as x increases, y is decreasing. So is this growth or is it decay? It's decay. Okay. So what is the initial value of the car? It was $15,000. Approximately how much will the car be worth after 5 years? So let's go check the calculator. Where it says 5, it's 6655.6. So we put that down. 6655 and 60 cents. Wow, that's a lot, huh? After how many years will the car be worth approximately half its original value? So half of 15 is roughly $750. Okay, so it's about between 4 and 5, so I'd say it's roughly 4.5 years. At roughly 4.5 years. All right, let's look at number 3. See, isn't this fun? This is one of my favorites. Okay, so John has an ant farm with 100 ants. The population of his ant farm will triple every month. So this equation will look like y equals what you start with, 100. What does triple mean? It goes up by 3, right? So it's 3 times. This one you're not going to do 1 plus or minus anything, because if it says triple, we're not dealing with percentages or anything. It's just 3. Okay? It triples. 3 to the power of x. So that one's going to be B. Okay, because triple is technically saying at 300%. Okay? That's why. And 1 is the 100. Anyway, don't worry about it. Just know if it says triple, you're going to put 3. All right, so we're going to make another table. So 0, 1, 2, and 3. So let's type in our equation. We have 100 times 3 to the power of x. Go to your table. Okay, after 0 months, so at the beginning, it starts with 100. After 1 month, there's 300, 2 month, 900, 3 month. Wow, that jumps really fast, huh, when you're tripling? So you start off with 100, then it went to 300, and then it went to 900, and then it went to 2,700. Okay, so is this growth? Okay. Well, as x increases, y increases, so this is growth. How many ants will John have after 3 months? Well, we have it right here. 2,700. That's a lot. How long will it take for John to get more than 10,000 ants? Okay, so we want this to be more than 10,000, or this side. So is 4 months more than 10,000? No. 5 months is definitely more. So 5 months to have more than 10,000 ants. 5 months. Okay. So this is basically what we're going to be doing. So flip over to the back side. Okay, so I'm going to do number 4 and number 7 with you. So number 4 says the population of New York City increased from this amount in the year 2000 to this amount in the year 2005. The annual rate of the population increased, which means go up, for the period was 4%, or 0.4%. Okay? So write an equation for the population t years after 2000. Okay, so 0.4% is going to be, when you move the decimal over twice, it's 0.004. It's increasing, so it's 1 plus 0.004. So the equation is going to be y equals, where do we start with? That big old number there, 8,008,278 times 1 plus this, so it's 1.004 to the power of x. Okay, so that's our equation. All right, or after t years, you can say to the power of t. Okay. Use the equation to predict the population of New York City in 2015. So what we're going to do is 2015. So this is what I have to tell you about dates. We're starting in the year 2000, right? 2000s are 0. So 2015 is how many years later? It's 15 years later, so this is our 15. You don't use the dates, you use these numbers. So we want 0 and 15. So in order to predict this population, we just need to make t 15. So I'm going to type that in. So we have the number let's get out of here. 8,008,278 times 1.004 to the power of, we want 2015, so to the power of 15. Hit enter. That's your population. 850,2464. And we can round it to 2 decimal places. 0.61. 0.61. Okay? So this is going to be the population predicted in 2015. Now, number 7. Let's look at number 7. Oh, I didn't renumber these. Okay, so it's numbered on your paper, so it's the one that says manufacturing. Number 4 on this paper, but number 7 on yours. Okay, Zeller Industries bought a piece of weaving equipment for $60,000. Okay, it is expected to depreciate, remember that D means going down, at an average rate of 10% per year. Okay, so you want to write an equation of the equipment after t years. Okay, so y equals, what do we start with? That's 60,000 times, now this is going down, so we're doing 1 minus 10%, which is 0.10. 1 minus 0.10 is 0.90. Okay, so we're doing times 0.90 to the power of t, or to the power of x. That's your equation. Then you'll need to find the piece of equipment, the value after 6 years, and you can do that on your own. Okay, so be sure to submit your answers online. Let me know if you need any help. This is due by the end of the class period. You can do it. Good luck, you guys.